everybody, welcome to a new video. Today we're going to solve the symmetric tree problem on LeetCode. So we will have a binary tree, we have the root of a binary tree, and we need to check if it's a mirror or if it's a symmetric tree. That means that we need to return a boolean. So what is a symmetric tree? I like it this way. You imagine this tree is a piece of paper, okay, and the tree is symmetric when if you fold that paper around its center, the nodes will be equal. So imagine with me in your head, we're gonna fold this paper in half, okay, around its center. So 2 will go to 2 and 4 will go to 4, okay, and 3 will go to 3. Okay, so this one is symmetric. But if I try to fold this one, 2 is going to be at the top of 2, but 3 and 3, no. 3 will be here at this point, okay, will be at this part. So that's incorrect, so this one is not a symmetric tree. Okay, so how are we going to approach this problem? We actually have two approaches. The first one is recursive and the other one is iterative. Let's start with the recursive one. We want to know if this binary tree is symmetric. So we're going to divide this problem into different subproblems. In order to know if this is symmetric, I need to make sure that those two are actually symmetric some way. And to make sure that these two are symmetric, I need to make sure that this subtree and this subtree are symmetric, and this subtree with this subtree are symmetric. Okay, so let's try to solve that. First of all, we will need a helper function. I'm going to call it helper, and it's going to take two inputs. The first one is T1, the first tree, and the second one is T2. Okay, so first of all, we need to do a check. Imagine if we had just one element here, like this. This is symmetric, but it has no left and it has no right. Both are equal to null. So if both T1 and T2 are null, so T1 equals to null and T2 is equal to null, we just can return true. Cool. But now if but there is another case. If imagine if I have this case and null. This is not symmetric, okay? And also the way around. This is not symmetric. Okay? So if T1 is equal to null or T2 is equal to null, return false. You're gonna tell me, but here we don't check that one of them is different, because here we could have both of them are different. But don't forget that we have this check first. Here we make sure that both of us are equal to null. And if we don't pass this condition, that means that one of them is different from null. Okay? Cool. Now there is another check we need to do. As always, the first thing that we need to do when we want to compare the two subtrees, the left and the right subtree, we need to check their roots, and they must be equal. That's why we need to put this condition: if T1 dot value different from T2 value, we return false too. Okay, and then we need some recursion. Now the next subtrees that we need to check is the left of this should be symmetric with the right of this, okay? and the same for this, the other way around. Okay, so helper T1 left, T2 right, and helper T2 right, T1 right, this time T2 left. Cool. Now we call our helper function here in the function return helper, and we call root left and root right. The initial root, we don't need it actually, doesn't matter its value. The most important thing is its children. Let's run the code. Hopefully we didn't make any mistakes. Cool. Actually, we can simplify this condition into this. If T1 or return T1 equals to T2. So this is the equivalent of the if statements that we had earlier. Okay, so if T1 is null and T2 is null, basically it's going to return true, and that's what we want. But if one of them is different from null, it's going to return false, and that's what we want too from the condition. So it's correct. Okay, I'm gonna run the code again, submit it, and it works perfect. Now let's see the iterative version. I'm gonna draw again the tree. We have 1 here, we have 2, we have 2 again, we have 3, we have 4, we have 4, and we have 3. Now the iterative approach. So the iterative approach is like we're going to traverse our tree by a level. And to traverse our tree by a level, the data structure that we will need is a queue. Initially, we're going to put into our queue the left and the right value of our root. So this is the initial state of our queue. Then we will have a loop to go through all the elements of our tree. In our first iteration, we're going to pop the 2 first elements of my queue. So we have a 2 here and we have a 2 here. And in the same way on the recursion, we're going to check these two nodes if they are null. So if in our case they're not null, but if we had like 2 null nodes, they must be either both null. But if we had like one of them is null, that means that it's not symmetric and we need to return false. Okay, but we don't have any case of this, so we just need to check if the nodes have the same values, and that's the case. Okay, so that's correct. And then we can, after removing them, we can add now into our queue. We can add now the left of this one, that is 3, and the right of this one, that is 3 again. And we add also the right of 2, that is 4, and the left of 2, that is 4. It's kind of the same way that we've did it in the recursion. Nice. Now we're going to go through the next iteration. We're going to remove 3 and 3. Okay. Now we have 3 and 3 as our nodes. Okay. Then again, I'm going to check if they are null or not. And depending on if they're both null or not, we can return false, or we can skip to the next iteration. But in our case, they are not null. Okay. So we just need to check their values. They're both equal, so we're cool. And now we can add what? The left of 3 that is null with the right of 3 that is null again, and we're gonna have a lot of nulls here. Okay, and we're going to continue the process until we have no more nodes. in our queue. Okay, so now let's write the code. I'm gonna remove this and remove this. As I said, we will need a queue of what? Of 3 nodes. I'm gonna call it queue, and it's gonna be a linked list. Okay. As I said, I'm going to initialize my queue. I need to add 3 node here. Linked list queue 3 node. I don't understand why it's not giving me, but it's okay. Okay, I'm gonna add here the root left and again the root right. Then I'll have my loop, and I need to check that the queue is not empty. Okay, and as I said, the first thing I'm going to do is I'm going to pop the 2 first elements or poll. Okay, and what I need to do is check if T1 is equal to null and T1 is equal to T2, or I can put like T2 is also equal to null. I can skip to the next iteration, okay? Because I cannot add the left and the right of the T1 and T2, they're both null, so it doesn't matter. I just need to go through the next iteration. If T1 is different from null or is equal to null, sorry, or T2 is equal to null. If I have one of them is equal to null, that means that it's false. We need to return false. It's not symmetric. Another case, if T1 value is different from T2 value, we return false here again. And after that, we can add in our queue the T1 left with what? I'll let you guess what I put here. Right. Yes, you guessed it right. Good job. Now here T1, I'm gonna put T1 right, but here what I'm going to put, yes, that it's it. Yes, that's the left. Yeah, cool, nice. Okay, and at the end, if we loop through all the elements and we have no return false, so we just return true, means that is correct. Okay, so let's run the code. Hopefully everything working fine. Yes, it does. Submit the code. Works perfectly. So before finishing the video, let's have a look about the time complexity. So for the recursive version, the time complexity would be O of n. Okay, and the O of n, because we're going to check and go through all the traverse all the elements of my tree, and also for the iterative version, also we will have an O and time complexity, and here the space complexity would be O of n. Watching, thank you for your support. See you in the next video. Bye.